Have you ever felt the wind on your face and wondered if you could actually hold air in your hand like an ice cube? We breathe air, live in it, but can't see it. Yet it's a real substance made of tiny particles zipping around. We see water freeze into ice all the time. So could we do the same with air? The answer is yes, air can become a solid, but it takes some extreme science. Just like water, air is made of molecules, and changing its state is all about energy and how close those molecules are. Imagine a dance party. In a gas, the dancers, molecules, are wild and free. In a solid, they're packed tight, barely moving. Our mission? Figure out how to calm those wild air molecules and lock them in place. This journey will take us into the heart of matter, exploring temperature, pressure, and the amazing science that lets us freeze the invisible. By the end, you'll know not just that air can be solid, but exactly how scientists make it happen. It's a process that reveals some of the coolest rules of our universe. So, get ready. Let's dive into the science of turning thin air into something you can actually hold. We'll see real-world examples, learn about the forces at play, and discover why this matters. Science is the key to unlocking these mysteries. Are you ready for a scientific adventure? Let's get started. The invisible is about to become visible. Welcome to the world where air becomes solid. Before we freeze air, let's figure out what it actually is. Air isn't just empty space, it's a mix of gases, like a giant invisible soup. The main ingredient? Nitrogen, about 78% of every breath you take. Next is oxygen, making up 21%, the gas that keeps us alive. Together, nitrogen and oxygen are almost all of the air around us. The last 1%? That's argon, carbon dioxide, water vapor, and tiny traces of other gases. Water vapor changes with the weather, making the air feel humid or dry. All these molecules are constantly bouncing around, invisible but real. When you wave your hand, you're moving through a sea of these particles. Understanding air as a physical mixture is the first step to freezing it. It's not magic, it's science. Each gas in air has its own properties and freezing points. Knowing what's in air helps us understand how to turn it solid. So air is a real tangible substance, just usually too spread out to see, and that's what makes freezing it such a fascinating challenge. Let's see how we can make the invisible visible. To freeze air, we need to understand the three main states of matter: gas, liquid, and solid. Matter is made of molecules, and their state depends on how much energy they have. In a gas like air, molecules are wild, zipping everywhere, far apart. Cool them down and they become a liquid, closer together, still moving but calmer. Cool them even more and they become a solid, packed tightly, barely moving, just vibrating in place. Think of it as a dance. Gas molecules are party animals, liquids are a slow crowd, solids are a tightly packed group, barely moving. The difference is all about energy and spacing. Changing from gas to solid is called a phase change. We're not changing what the molecules are made of, just how they behave. Our goal? Take air's high-energy, spread-out molecules and force them to slow down and lock together. This is the science behind freezing air. It's all about controlling energy. The right conditions can turn even the wildest gas into a solid. That's the magic of phase changes. Next, let's see how temperature and pressure make it happen. Ready to turn down the energy? Let's go. How do we change air from a gas to a solid? With two tools: temperature and pressure. Temperature measures how fast molecules move. Hot means fast, cold means slow. To freeze air, we need to make it unimaginably cold, far colder than any winter day or even your freezer. Air turns to liquid at minus 196 degrees Celsius, minus 321 degrees Fahrenheit, and to solid at minus 213 degrees Celsius, minus 351 degrees Fahrenheit. But temperature isn't enough. We also need pressure. Pressure squeezes molecules closer together, making it easier for them to stick. Imagine packing a suitcase. The more you press, the more you can fit. Scientists combine high pressure with extreme cold to force air into a liquid, then a solid. First, they compress the air, then cool it down. The compressed air is easier to chill into a liquid, and with more cooling, into a solid. It's a delicate balance. Push the molecules together, then steal their energy away. This is how we guide air through its phase changes. Without both tools, air stays a gas. But with the right combo, we can make the impossible happen. That's the secret to solid air. Let's see it in action. You might have seen liquid nitrogen in science demos or fancy ice cream shops. That's nitrogen, the main part of air, chilled so cold it becomes a liquid. At minus 196 degrees Celsius, it pours like water, but it's dangerously cold. The white clouds you see aren't nitrogen but frozen water vapor from the air. Liquid nitrogen is just the first step. Scientists go even colder in labs. Using special machines, they reach temperatures near absolute zero, where molecules barely move. In these labs, air can be cooled until it freezes solid, a pale, bluish block. This field is called cryogenics, and it helps us understand matter at its limits. Freezing air isn't just for fun, it reveals new properties and helps develop amazing technologies. Each experiment adds to our knowledge of how the universe works. Turning air solid is science at its coolest. So, how do scientists actually freeze air? First, they purify it, removing water vapor, dust, and carbon dioxide, which would freeze too soon. Next, they compress the clean air to high pressure, squeezing the molecules close together. This compression heats the air, so it's cooled back down using heat exchangers. Then comes the magic rapid expansion through a valve, which makes the air super cold, thanks to the Joule-Thomson effect. This cycle of compressing, cooling, and expanding repeats, dropping the temperature lower each time. Eventually, the air condenses into a pale blue liquid at minus 196 degrees Celsius. To get solid air, they cool the liquid even further, down to minus 213 degrees Celsius. The liquid thickens, then freezes into a brittle, bluish-white solid. The result? A block of solid air, something you can actually see and touch with the right protection. It's a precise, high-tech process, and it all starts with the air we breathe. That's how science makes the invisible, visible. If air can be solid, why don't we see it happen outside? The answer: Earth just isn't cold enough. The coldest place on Earth, Antarctica, only gets to minus 89 degrees Celsius, nowhere near the minus 213 degrees Celsius needed to freeze air. Our atmosphere and the sun keep things far too warm for air to turn solid naturally. But on other worlds, it's a different story. Mars has dry ice, frozen carbon dioxide, at its poles. On Pluto, temperatures drop so low that nitrogen, the main part of air, freezes and falls as snow. So, while you won't find air cubes in your backyard, they exist on distant planets and moons. Earth's conditions keep our air breathable and invisible, a good thing for life. Creating solid air in a lab is a scientific achievement, not a natural event here. It shows just how extreme and impressive our technology can be. The invisible ocean of air around us will stay a gas, unless we step into the lab. And that's what makes solid air so special. Turning air solid isn't just a science trick, it's packed with cool facts and real-world impact. Not all air freezes at once. Oxygen and nitrogen have slightly different freezing points, so solid air is a mix of crystals. If you held a block of solid air with special tongs, it would instantly sublimate, turning straight from solid to gas. That's the same thing dry ice does. The process of freezing air helps us separate its gases for industry. Pure oxygen is vital in hospitals and manufacturing. Pure nitrogen preserves food and powers science demos. Studying matter at extreme cold leads to new materials and technologies like superconductors. It also deepens our understanding of physics and chemistry. Exploring questions like, can you freeze air, pushes science forward. It's about discovery, innovation, and seeing the world in a new way. The air around us is full of secrets, waiting for science to unlock them, and that's why it matters. We started with a wild question: can you turn air into a solid? Science says yes. Air is a real mixture of gases, and with the right conditions it can be frozen solid. It's all about energy. Wild molecules become calm and locked in place. Scientists use extreme cold and pressure to make this transformation happen. We don't see solid air on Earth, but it exists in labs and on distant worlds. The technology behind freezing air gives us vital tools, from medical oxygen to food preservation. Science lets us see the extraordinary in the ordinary. Even the invisible air around us has secrets to reveal. All it takes is curiosity and a little bit of science. That's the solid truth about air.